Okay, today we're going to learn how to solve or to write proofs using Cpctc, which stands for corresponding parts of congruent triangles are congruent. Please make sure that you take out a sheet of loose leaf paper if you chose not to print out these notes. So the first thing we have to understand is what corresponds to what. So if we look at what's given to us on the top, it says triangle ABC is congruent to triangle DEF. Since A is first and D is first, that means angle A lines up with angle D. So angle A corresponds or is congruent to angle D. Since B is second and E is second, that means B and E correspond. So angle B is congruent to angle E. And since angle C and letter F are third, that means that C corresponds to F. So angle C is congruent to angle F. Now the corresponding sides, if we look at this, if we look at AB, that goes from red to blue. So on the other triangle, red to blue is DE. So we can say that AB is congruent to DE. If we look at the next side on the left triangle, blue to green, and over here, blue to green. So BC is congruent to EF. And if we look at the last side of the first triangle, AC, red to green, lines up with FD, or DF, red to green. So AC is congruent to DF. Those are the pieces that line up with each other or correspond with each other. So when using Cpctc in a proof, you must first prove that the triangles are congruent, and then we're going to move on and prove that the parts are congruent. So if I look at the first example here, for number one, like any proof, I'm going to start with the givens. So AB is congruent to DE, AB, DE. Angle B is congruent to angle E. So I'm going to mark my picture. And BC is congruent to EF. So BC and EF. Those are given. I'm going to also mark off to the side AB, that's a side. The angles are obviously an angle. And the third one is an actual side of each of those triangles. So if I look going down the left column, I have a side, an angle, and a side. Look at the picture. I have a side, an angle, and a side in that order. So I can say that triangle ABC is congruent to triangle DEF, and the reason is side, angle, side, is congruent to side, angle, side. Now, the question is not asking me to prove the triangles, it's asking me to prove that angle C and angle F. So they want me to prove angle C and angle F. Since I proved that the triangles are congruent, the last line in my proof can be that angle C is congruent to angle F, and you can write the letters, but I want you to say it in your head every time you write it. Corresponding parts of congruent triangles are congruent. It's very important that you get these letters correct, because when we do similar proofs later on, we're going to use that corresponding parts of similar triangles are in proportion. So we want to make sure that we understand this stands for corresponding parts of congruent triangles are congruent. Okay, if we look at the next example, it says prove angle 1 is congruent to angle 2. So if I look at angle 1 and angle 2, hopefully you can see that angle 1 is in this blue triangle here, and angle 2 is in this red triangle here. So if I can prove those two triangles are congruent, I can say those angles are congruent. So I'm going to start with the given. It says G is the midpoint of, and it's cut off here because I zoomed in, FH. And it tells me that EF is congruent to EH. That's number 1 is given. Now, if I look at what's given to me, G is the midpoint. That doesn't give me a side or an angle. EF, this piece here, is congruent to EH. That gives me a side. So for step 2, I'm going to define this right here. If G is the midpoint of FH, this bottom piece here, I can say that FG is congruent to GH. And the reason, a midpoint cuts a segment into 2 congruent pieces. That takes care of that step. And if I mark my picture, that gives me a side. Now, if I look, I have no more given information. So when we're stuck, we always look for the reflexive property, meaning does the blue triangle and the red triangle share a side or an angle? Or we look for vertical angles. In this case, we can say that GE is congruent to GE by the reflexive property. Because it's in both triangles. That gives me a side. Now I can say that triangle FEG is congruent to triangle HEG. And the reason being side, side, side is congruent to side, side, side. Now, since those triangles are congruent, my last step is angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. Okay, the last example here. It says prove angle A is congruent to angle B. So if I look at the picture, angle A is here and angle B is here. Hopefully, you realize that angle A is in this triangle here and angle B is in this green triangle here. So if I can prove those triangles are congruent, I can say the angles are congruent. So I'm going to start by writing the given. AE is perpendicular to EC. BC is perpendicular to EC. AD is congruent to BD. And D is midpoint of EC. Those are given. Now, if I mark my picture, AE is perpendicular to EC. That tells me this. And if BC is perpendicular to EC, that tells me this. So I can start with that and say angle E and angle C are right angles. The reason being, perpendicular lines form right angles. Now, in your head, you should say, well, I know they're both 90, so they must be equal. So angle E is congruent to angle C because all right angles are congruent. I'm going to put a little X by that line, a little X by this line because I've defined them, and I'm going to mark next to number 3 with an A for angle. Now, if I look at the second piece of given information, it says AD is congruent to BD. That gives me a side. If I look at the third piece of information, it says D is the midpoint of EC, so it's the midpoint of this bottom piece. Hopefully you remember that a midpoint cuts a segment into 2 congruent pieces, so ED and DC are congruent, so ED is congruent to DC, and the reason a midpoint cuts a segment into 2 congruent pieces. That gives me a side. Now, if I look at the way they came out in the picture, I kind of have an angle side side. I can't use a bad word when I'm doing my proof, but I do realize that both of those triangles have a right angle, so I can say triangle AED and triangle BCD are right triangles. I know that because a triangle with a right angle is a right triangle. Now, instead of writing angle side side, which is a bad word, I can say that triangle AED is congruent to triangle BCD by hypotenuse leg, congruent to hypotenuse leg. Now, since the two triangles are congruent, my last step of the proof is going to be that angle A is congruent to angle B because corresponding parts of congruent triangles are congruent. Please make sure that you write down any questions and either email me or ask me next time you see me in class.